of the 300 people who've registered, more than 300 people who've registered online so far. I'm sure more people will join as they navigate through the process of connecting into the Zoom. But for those who have joined so far, hello and welcome from wherever you are. I know we've got, as always, many of our Indonesian colleagues online, as well as many of our Australian colleagues, and also today many Sri Lankans, as well as people scattered around all other parts of the world. So this is the fourth in the international webinar series that we've been trying to hold for the last few months, and as a little way of trying to stay connected. For those of us who were always who were able to talk to each other face to face and travel to meet each other, this is a way for us to stay connected, exchange ideas, and generally keep working together. So it's I've enjoyed it. I'm sure everyone else is enjoying it. And today we've got some excellent speakers. It's going to be World Mangrove Day on Sunday, so we're going to start with a couple of mangrove talks in recognition of World Mangrove Day. Just in terms of how we operate, so there is a chat box, so all the participants can chat to each other or exchange their notes. If you want questions for the panelists, which we will answer at the end, there is a Q&A tab down the bottom of your screen, or at least it's down the bottom of my screen. And so type your questions in there and type who you would like to answer. And at the end of the presentations, we will have a session where we start answering those questions. So all the presenters will have about 12 minutes each. So that will take about an hour, which will leave us to about 45, 50 minutes to go through some questions. So that's it from me. I want to hand over to my good friend and colleague, Andreas, to do an introduction. Over to you, Andreas.
Yeah, so it's already starting.
Yes.
Okay. Good what afternoon and good evening, distinguished panelists, and also ladies and gentlemen, and all of the audience. It's a great pleasure for us to have you here and discuss about some very good issue regarding the restoration. So I would like to share a bit some history about what is going on. Matt already mentioned about the series. I think just remind you, most of you, that we have already starting a few months ago about the first series. At the time, we are talking mostly about the blue economy after COVID-19 pandemic. So we are trying to see, to search some opportunity for recovery and resilience in the ocean and archipelago state. So it's rather more on the policy aspect of a big umbrella on blue economy. And after that, we have followed by the second and the third webinar is about blue carbon for sustainable blue economy. And the last one before about livelihood and marine conservation. So they have some sequence here that we've during the session about blue carbon, we found some issue about the livelihood and marine conservation as a key for sustainable blue economy, particularly in the framework of the blue carbon. So we are trying to find out from the third webinar that how we could able to give some information or an outlook about the women empowerment and then governance for the effectiveness of marine conservation and coastal community livelihood. So this is, and from this webinar, we follow by now that one of the key issues is about the restoration. I think natural restoration is a very big issue, it's a global issue. And now on commemoration of the International Day for the Mangrove Ecosystem, we would like to enhance our cares, their understanding how important mangrove ecosystem for in the coastal ecosystem, also in link with another ecosystem such as seagrass and also coral reef. So those three coastal ecosystem are key of how we could able to manage our coastal environment in the sustainable way. And here we have excellent speakers from different regions. They have on what experience and knowledge about their idea about the restoration issue, mangrove and as well as the coral reef and seagrass, maybe some of them. And I think it's a great honor to have you guys here and hoping we could able to find out something, enhance our understanding and knowledge about this issue. I think good luck for all speakers and also to the moderator. I would like to give the floor to you, Matt. Thank you.
Thank you, Andreas. So I think that's it for the introductory comments. Just to note that for those who are unable to watch it, there will be a YouTube link at the end of it. Those YouTube links have been very popular. Of the webinars that Andreas has mentioned, they've been viewed more than 2,500 times so far. So they've been useful because not everybody can join. So without further ado, and in recognition of World Mangrove Day again, I will hand over to Freda Siddiq as our first speaker. So Freda is a senior researcher at the Institute for Marine Research and Observation, which is based in Bali, in a very nice part of Bali, I must say. And the institute's within the Ministry of Marine Affairs and Fisheries. Freda is a mangrove ecologist, and in her job at IMRO, she's running a mangrove lab that supports science-based policies for mangrove restoration, coastal zone management, as well as climate change mitigation and adaptation. So Freda's been involved in many things, and one of the notable ones is Freda was a fellow of the ASEAN US Science and Technology Program on Climate Change just a year or two ago. So Freda, perhaps share your screen and over to you.
Okay, thank you, Matt and Andres. So I will share my presentation here. Okay, there you go. All right. Good afternoon, everyone. Good evening, or even good morning for some people. My name is Freda. I'm working for the Ministry of Environment and Fisheries. So today I would like to share a little bit my experience, how to get the benefit from mangrove restoration from the climate change mitigation. So people already know that mangrove is a coastal ecosystem living in the intertidal area, spreading along the tropicals and subtropical region. And if you can see from the slide here that most of the mangrove are sitting in the Southeast Asia region. And based on the topology settings, that most of the mangrove are kind of the delta settings. So, okay. Oops. Okay. But now we have like a growing concern about the mangrove, that we have the change of the mangrove forest extent. We have the very like in the number of the countries we face a lot of mangrove loss, and there are many studies assessing how the mangrove is rapidly decline, and there are some maps we got from the studies such as from Worthington and Spalding and Thomas, showing that there are some hotspots in the region, some regions in the global, where mangrove are are rapidly declining here. And if you look down, what's happened to the mangrove? What are the main drivers of the mangrove loss? Here, like in Indonesia, the country which is the richest country, which has a lot of mangrove, #1 mangrove area, the largest mangrove area in the global. We can see here that the major drivers are the conversion from mangrove forest to the ponds, or we call here tambak. And there's like a very rapid decline of mangrove since early 1980s. And here that, hang on. Okay, let's start here. Okay. And in addition to the human impact, there is also the natural disaster that caused the decline of mangroves, such as coastal erosion. As you can see here, like in Malaysia, and even like in South America, where the erosion is very massive, the big mangrove can die, and then they can stand on the coast. But the good news that many countries, the government, the community, NGO already has set up plans, a program of restoration. And there is like a very interesting study about how mangrove restoration has potential. This study collects about 160 projects around the 24 countries, and they identify that there are a number of success and failures in mangrove restoration. And the success is about 60 to 90% of the survivals until, after the 10 years of restoration. And they also record the failures mostly are because the poor planning of the mangrove restoration, and also people want to get a very quick result from the restoration, desire for a rapid fix of the restoration, and they don't have any background on ecology about what is the mangrove, how the mangrove can grow, and also they got the wrong location and wrong species to be planted. And this is a very interesting picture about where mangrove can best live. Many people doesn't really understand that mangrove are site-specific. They cannot live everywhere in the coastline. They need like an environment where they can grow. Like here in the picture, you can see that the best location they can live is about the intertidal. So many restoration or rehabilitation put the mangrove, like plant the mangrove above or below the mean sea level. This is for example, like in Indonesia or Philippines or other countries, they put the they plant the mangrove in the mudflat and maybe on the seagrass, so they can have a mangrove, but they kill the seagrass. And also here, there's the questions like, do we really need to plant the mangrove? So actually, if we talk about the restoration, especially for restoration, plantation is only one component of the restoration. It's about the vegetation. But here we have another two important components when we want to do the mangrove restoration. They are sediments and hydrology. So the problem is most of the people, the project overlook this fundamental process. So they don't care about the sediment, they don't care about hydrology, they just plant it. Maybe they planted in the wrong site. So what's happened is they meet the failures, but then the failures actually can be predicted if you really understand the system, and then it can be avoided with the minimum of guidance, not only for ecological, but also for socioeconomics. And why sediment is very important? There's another guidance, very interesting guidance about why sediment is very important. the restoration success is determined by sediment supply and hydrodynamic condition. So this guidance show you that, let's say, mangrove are kind of opportunistic plants. They take advantage from the calm environment, and if they have adequate sediment supply. So if don't have adequate sediment supply, so they means that they cannot survive. So when they have a very optimal condition, without any plantation, they can have the natural generation, and then they can rapidly grow. But what happened now? If we have sort of like human intervention, let's say they block the hydrology, or maybe they convert the mangrove forest into the other land use. So what's happened is sediment supply will be changing. And then probably sediment supply is lacking and mangrove will face sediment deficit. And also what's happened is the soil surface elevation might be changed. And then the mangrove inundation period may be longer or maybe shorter. So mangrove cannot stand, and then what happened is the mangrove will be degraded and maybe they die. So there's another guidance for mangrove restoration. It is very interesting to it can help people to set up the restoration plan. So from this website, you can find, let's say, in Indonesia, this country has sort of like potential area to be restored mangrove. This is about 186,000 hectares. And then not only the area that can be restorable, but also they can also estimate the benefit from that kind of restoration. Here is the benefit that we have for the soil organic carbon and above ground carbon. So as we have heard about the issue about the blue carbon, so this kind of potential is very important for us. So now we can see how the soil organic carbon and above ground carbon can be obtained from the restoration. So this is one of the literature studies showing how important is the not only plantation but also the sediment and hydrology to get the benefit of restoration for climate change mitigation. We take some example from the abandoned ponds where the mangrove restored in this area. So from those studies, they show that the reintroduction of tidal flow to restore mangrove is currently the most promising blue carbon. And then maybe people want to know how the restoration of mangrove, especially in the abandoned ponds, is very important for the blue carbon activities. So this is one of the example of this of the study in Bali. So we have kind of abandoned ponds in this area where mangrove in the early 1980s, people start to replant the mangrove in some sites, and then, but then in the natural regeneration comes through the site, through the damaged wall of the ponds. So within the 15 years, the mangrove growing both from the replantation and also from the regeneration without any plantation. So it's kind of like a mix. There's kind of a mixed mangrove regeneration here. Like after the tidal reinstatement in the ponds, we have like two different regeneration for the natural recruits and the plantation. Here we have the restoration site, where in the beginning of 2000, there is no mangrove at all, the same like in the reference sites. But within the years, after 7 years, the site with the plantation, we have about 8% of the area covered by mangrove. The reference site is the area without any plantation. And then we can see after 10 years, the natural recruits is about 84% covering the area, while the plantation is only about 27%. So we can see here that the natural regeneration is overpassing the plantation. And it's also interesting to see that after 10 years of restoration, the restored area can have like restoring the components of the carbon system. So the carbon accumulation is similar to the reference area. Okay, this is my last slide. Here we can see that if we do restoration in appropriate approach, we can have, we can get the climate benefit, climate change mitigation benefit. And if we can see from the table, let's say if all the restorable area can be restored with the appropriate approach, like in Indonesia, we can estimate that 97 million soil carbon can be restored from this area. So it's quite a lot of the carbon in this area. So I think that's all from me now. Thank you for the time and happy Mangrove Day.
Terima kasih, Freda, and happy Mangrove Day. Thank you. I'm really interested to see the last set of slides. I haven't seen that information before. Freda, that's new for me, the comparison of the hydrological restoration versus plantation. That's going to be a very important contribution. We need that sort of evidence in order to make really good decisions about how we're going to restore ecosystems. So thank you, Freda. And for those who have just joined, remember there's a question and answer facility at the bottom of your screen. We've already got one question in, and over the course of the presentations, please add your questions and we will address them at the end. So from mangroves in Bali to mangroves in Sri Lanka, I would like to introduce Dr. Sawandi Jayakoldi. Sawandi is a senior lecturer at Wayamba University, which is, I think I recall, on the western part of Sri Lanka. Sawandi is also chair of the Mangrove Expert Committee in Sri Lanka, and that is a very active committee doing some very excellent work. I suspect we'll hear a little bit about it now. Sawandi has a PhD in zoology from Aberdeen University, and I know that as well as working on mangroves, Sawandi's been thinking about elephants and all sorts of other things in the last few years. So please, Sawandi, over to you. Excellent. So we can't hear you yet. I think you're still on mute. There we go. We can now hear you. Maybe put it on full screen mode or slideshow mode, and off we go. Thank you, Sawandi.
Thank you, everyone. Good morning, good afternoon, and perhaps to some of you, good evening. Happy Mangroves Day to start with. And yes, I think Freda set the background for my talk, and I would like to take on from there, where I would like to talk about restoration with a different angle. That is sort of like sharing with you some eureka moments that we had in restoring mangroves. And also to emphasize something that Freda also emphasized, that minimal invention and careful observations of what's really happening in the field really helps you to do things properly. So with that note, let me take you through my slides, and also I would like to do this as a story because it's actually a story of what we encountered and how we did things in Sri Lanka when it comes to restoring abandoned shrimp farms as well as saltons in Sri Lanka. So I'm very sure for most of you, this is a very familiar site, what I'm showing here. An abandoned salton, abandoned for the last like 10, 15 years. But you can see the amount of disturbance that we've done to the environment and how difficult it is for any life to come back and to settle in. But yet, if for the keen eyes, if you really look into this system, still there are little clues, and nature itself becomes the guiding star for us to understand how restoration can be effectively done. So in this same site where you see a very harsh condition with all acidic soil on the surface, yet if you look at the sides, there's a different story. That's because one little sluice gate that was set aside, that was open to the system, has been bringing in water, cleansing the system, bringing in the seeds, and creating an environment, right sediments, right soil conditions, and right hydrology, so that the plants can settle in again. When Sri Lanka started its restoration attempts, the very first thing we did was going around the country and observing all these things and understanding how the nature had actually been trying to restore the systems that we were trying to destroy. So you can see here very clearly how a tiny bit of water, if it comes on the right time, from the right direction, can restore an abandoned shrimp farm or a saltern. So what we saw and what we observed is that when it comes to restoration, some of the models that are already there in the environment. All we need to do is to make sure that we follow the path, and also we follow the system and try to understand how we can mimic it. I think that was the sort of game that we were trying to sort of like play with restoration in Sri Lanka. So this window of opportunity, if you really clearly understand it, can be introduced to other systems, can be tested at a pilot level. So when the Mangrove Task Force was established by the government of Sri Lanka, because we have set a very ambitious target of restoring 10,000 hectares of mangroves. In order to go there, what we really wanted to check was, how do we go beyond replanting? How do we mimic what the nature does? So that was a model that Freda just mentioned. Combining planting, combining hydrology, combining sedimentation, and bringing in all these three components. But before doing it at the ground level, what we really did was checking it actually happening in the field, in reality, without our intervention. So that window of opportunity was our power. So the area that I showed you earlier, which looked very much like a desert, was then converted into something like this. If a sluice gate can do such a change and bring in the plants and restore a system naturally, why don't we do the same? So as a result, one of the very first pilot scale things that we did was cutting channels like palm fronds so that sufficient water comes in through the lagoon, flushes the soil, brings in the sediment, and conditions the system even before we think of planting. So we were basically following the clues of the nature. If you go to Google Earth these days and focus on Sri Lanka, an area called Pubudugama in northwestern province, you will see something like this. The palm front that we have created, you see the lagoon this side and the water channels that we have created. I also want you to pay your attention to the areas that have already been sort of restored naturally. Wherever you see natural restoration, that's the areas that were fortunate enough to get the sediment and the water. Yet you could also see areas that was not that fortunate enough. And that's where our intervention actually came in. So once the water channel started conditioning the land, then it was very easy for us to mimic what was in the surrounding. So in order to make sure that we go by the call of the nature, what we really did was, while this areas that were earmarked for restoration was conditioned, we did comprehensive studies to understand the mangrove cover in the periphery. What are the species? What are the species richness, their density? Not just that, from the lagoon front to the landward, what are the zonations? How have they distributed themselves? And accordingly, the same structure was mimicked. And I must tell you that with the previous replanting experiences, we had an idea what really are the hardy species that can actually settle in first and then allow the other species to come in. These channels were also an opportunity to ensure that naturally the seeds would arrive to the system and that they would regenerate. And you can see it happening already in some parts where the restoration attempts are ongoing. I'm showing you things that started in 2019, not very far. Therefore, we are yet to see the real full impact, but you can see what's happening at the moment. What we understood to date with our little experience is that where nature, or rather the natural mangrove cover, had been kept intact, in such areas, restoring mangroves is quite easy. It's like that the right condition is already there. It's like other plants welcoming what we plant. So the plants that we, the Rhizopora and Avicennia marina that we planted in areas, abandoned shrimp ponds, which were surrounded by natural mangrove itself, had a better survival. They did really well and they were happy. And we understood the challenge of restoring areas where the mangrove cover was totally destroyed. That gave us an idea the amount of efforts that we need to take in order to make sure that things happen properly, and also the amount of knowledge we need to gather even before we think of replanting. Now, with all this, by now, between 2019 and 2020, Department of Forest has already reforested, or rather replanted, 382 hectares of abandoned shrimp farms and saltons. We call this accelerated natural regeneration. That's our program. So we give a small push to what is happening, and we tend to go by what I told you at the very beginning, understanding what the nature does and mimicking what really happens by nature. Regeneration and replanting, all these things requires looking beyond and thinking beyond what we used to. So what we used to earlier is having nurseries and having plants grown somewhere, bringing them in and planting them. As Freda said, sometimes even planting in the wrong place. In addition to working out what are the ideal places to replant, we also wanted to work out how we can come up with novel ways to get quality plants, seedlings. So the hands that you see here belongs to a forester called Manjula. Over here, you can see something that, and a wild idea he tried. Abyssinia marina seeds are very much like cashew for crabs. They love it. And one of the biggest problems we had was crab predation, and most of our seedlings and even the seeds being eaten by crabs. So Manjula did something quite wild. He put seeds into a gunny bag, hang it in the lagoon for a while, and that avoided predation, and something interesting happened. We had a very high survival of or very high germination of the seeds. Not just the germination, that also allowed us to select the quality seedlings and then take them to the nurseries. We also followed the nature in a different way. This is our previous model. With the communities, with other stakeholders, plants were grown elsewhere, and once the plants are of the good quality and of the correct height, they were taken for replanting. But what we really did was in 2019 something different. When a site was selected, we wanted to make sure that seedlings are acclimatized, the plants understand where they are expected to grow, so that only the hardy species would remain, and those hardy species would be collected for our restoration activities. When we did this, we were not very sure that this will be a successful venture, but we really wanted to try new things because we, as I told you earlier, we really wanted to follow the call of the nature. And I would like to show you what is happening at the moment. Same site, this is 2019 and here's 2020. You can see how happy the plants are in the same condition and under the same sort of physiochemical conditions. So now these plants, once they are taken to the plantation sites, which is the same location to be frank, they tend to be having a better survival. I really don't have the statistics per se, because as I told you, we've just started. In another 5-6 years, we might be able to talk with the data, analyze data, but at the moment, it's just a story and sharing of our ideas. To follow the call of the nature, we also wanted to understand what was happening in certain specific locations. Especially in the arid zone, we have stunted mangroves. They are stunted for a reason. The harsh conditions in the arid zone, especially for species like Abyssinia marina, you tend to find plants that are so old, but they are totally stunted, some as short as like 6 inches, very old plants. But one thing we understood was that they are stunted not just because of the harsh conditions, they are stunted because of excessive grazing that is happening. We also saw where plants had the opportunity to grow without being grazed, they were doing differently. They were actually struggling and surviving in such a way so that with the right condition, they were coming up, popping up, and turning into bigger trees. And we really wanted to see if you liberate these kind of stunted Abyssinia marina, will it change its morphology? And to do that, Department of Forest again selected certain areas, and we fenced off certain mangrove stands while doing restoration to see whether liberation from predation can actually help. And you can see very clearly what's really happening. And it's heartening to see in the absence of excessive grazing or absence of grazing, these stunted plants are raising. And compare them with the salt marsh vegetation that is there. And now you can see how quickly they are coming up. So in another way, again, following the call of the nature. And I just wanted to share with you this slide to show you 2019, we came up with the fence in, and you can see by 2020, the flush growth of Avicennia marina. So again, a very good example. If you follow the clues from the nature, restoration can be minimally invasive. So here's my last slide. Lessons so far. I think restoration of mangrove ecosystems can be done if we follow the clues given by the nature itself. And I think it's also important to emphasize that restoration can be minimally invasive. And I think that's exactly what we must try and do. And at last, I must tell you that in doing restoration, especially mangrove restoration, we should never be nostalgic. We may not get what is in the periphery, but let's look for something that nature is willing to give us with the conditions that we provide. With that, I would like to thank Ministry of Environment and Wildlife, especially Mr. Dissanayake, for supporting all these activities, Biodiversity Secretariat, Department of Forest, and Mr. Sumana Dasa, and CSIRO, and all of you for giving this opportunity to Sri Lanka. Thank you.
Thank you, Sawandi Stuti. And another, to me, really exciting example of what we can do if we test a few ideas. And I think the lessons that we're learning from the work that Freda's been doing in Bali and that we're seeing in Sri Lanka and other places are really what is possible. And now we can start thinking about what is it that we're trying to achieve. You know, questions like, are we trying to simply replace what we lost? Or are we trying to achieve something else? Freda gave the example of carbon, you know, as a contribution to climate mitigation, but we can also think about it as how can we contribute to livelihoods through fisheries, which I think in a post-COVID world is also going to be important. So really exciting and important examples of how to think through those questions. So, but moving from mangroves in the Indian Ocean to plants that are not really plants in the Pacific Ocean, I will introduce Melanie. Now let me find, I'm sorry, Melinda. So Melinda is a principal research scientist with New South Wales Fisheries over on the east coast of Australia, and she leads a team including some postdocs and student that studies kelp forest ecology and uses genomics to inform conservation, management and restoration. So Melinda was part of the Operation Cray team, which is a really successful restoration effort that I think we're going to hear about, which successfully restored lost underwater forests to the Sydney coast and won a Green Globe Award for the efforts. I can also tell you a little secret that Melinda was part of a team that swam from Perth to Rottnest earlier on this year, and that's a distance of 20 or so kilometres. So Melinda's got a few skills up her sleeve. So without any further from me, over to you, Melinda.
Thanks, Matt. I'll just share my screen here. Can everyone see that now?
Yes, we can.
So, yep, I'll just get started then. Yeah, so what I want to talk about today is restoring underwater kelp forests, and this is work that I've been involved in for over a decade now, and I guess I just acknowledge all of my collaborators at different universities throughout Australia, but also a whole bunch of different sort of funding agencies that have sort of helped us over the years. So I guess I'm sort of preaching to the converted here when I tell you how important underwater seaweed forests are. They obviously support an immense amount of biodiversity. They provide all these really important ecosystem goods and services, and are just hugely valuable in an ecological but also an economic sense. And similar to the stories we've sort of heard today, seaweed forests are also in global decline. And some of the places that we've seen declines include Europe, Japan, Korea, the US, and Australia is no exception. So in Australia, what we've started to see are poleward shifts in distribution, both on the east and west coast, so Western Australia and New South Wales. but also declines in places like Tassie due to encroaching sea urchins and marine heat waves, South Australia and New South Wales due to poor water quality as well. But wherever I think we see these declines in the world, we tend to see this quite common sequence of events where a really, beautiful and diverse kelp forest, is subject to some kind of stressor. Usually it's impacted directly, but indirect effects also sort of come into play, and we get these transitions to these more depauperate and less desirable habitats, things like turf forming seaweeds, but also birch and barrens. And I've just put an example here of one particular decline in the cover of seaweed forests over a 40-year period from the 1970s to the present day, and this is quite common all over the world. And I think another commonality is that, where we've seen these declines of seaweed forests, we're not seeing any kind of natural recovery. So these regime shifts to these alternate states appear to be quite permanent, which has really prompted all these calls for restoration. There have been quite a few attempts at restoration of seaweed forests globally, but most of them have actually failed. And I'm sure that everyone can appreciate that's simply because, working underwater, working in any kind of marine environment is hugely challenging. For seaweed forests, obviously we're working in extremely wave-swept habitats. We are trying to, attach engineered structures to the rock. It involves trained scuba divers, underwater equipment. And for many of these reasons, it's also extremely costly. So some of the estimates we've pulled out of papers are up to $160 per metre squared. I personally think that's a real underestimate. That doesn't include costs of things like
Mel, we're starting to lose some of your audio.
monitoring or any paper that we've got in review at the moment, sort of projects, and found that my internet connection is unstable, it says. So I guess I'll just forge ahead and hope for the best.
Yep, you're back, so that's good.
Okay, sorry, yeah, I just had an internet dropout. Some of the common elements to successful seaweed restoration projects are that they tend to be backed by really long-term financial and institutional support. So I'm talking decades worth of funding by governments. So the example that I want to talk about today is Operation Crayweed, which really is among one of the most successful kelp restoration programs globally. And I've just put a link there to our website and Facebook page and Twitter account if anyone wants more information. But crayweed is this beautiful sort of golden seaweed here in the middle picture. It occurs along a lot of the temperate coastline of Australia, from the north coast of New South Wales all the way around Tasmania through to South Australia. It accounts for a massive biomass where it occurs, but it also underpins a huge amount of biodiversity, both in situ, but also as a spatial subsidy when it washes up into adjacent habitats. And back in about 2008, we discovered that crayweed, or Philospora, has actually gone completely missing from about 70 kilometres of urbanised coastline around Sydney. And I guess keeping in mind, this is probably Australia's most populated and most urban coastline, so it's pretty subject to anthropogenic impacts. So we knew from a lot of historical records, photographs, herbarium specimens, and surveys with scientists that have been working in the area for decades, that crayweed used to be abundant all along the shores of Sydney. And our more contemporary surveys, where we went back to over 50 reefs where we knew that it once occurred, we couldn't find a single crayweed plant. So it really was completely locally extinct from this 70-kilometre stretch of coast. However, it's still quite common to the north and the south of Sydney. So this sort of got us thinking that it was, an ideal candidate for some sort of restoration program. I think before we started restoration, and again, this is sort of probably important for any kind of restoration program, it's sort of important to go through this sort of decision framework, because there are certainly going to be some instances where it's not feasible to restore something. And, given the really limited amount of resources that are often available for restoration program, it's really important to make sure that you are doing the right thing and that you are able to restore something. So for crayweed, we sort of followed this process here. Doesn't don't know whether you guys can see my mouse here, but I'll just sort of go through this for Operation Crayweed. So the green sort of things are things that we already knew, and the red arrows and things are scientific questions that we needed to answer to get to the point where we were ready to restore. So we knew that restoration was going to be needed. Crayweed was not coming back by itself. We knew that it was possible to return the environment to its pre-loss state, and indeed it already had. Sydney installed deep water sewage outfalls in the 1980s, which immensely improved the water quality around those beaches, and that was what we think was the initial cause of decline of crayweed. We knew that hysteresis probably wasn't present. That's more associated with sort of urchin barrens in the case of kelp forests. We knew that there was not a sufficient source of local propagules to allow natural recovery. Obviously, crayweed had gone completely extinct from this 70-kilometre stretch of coast. So I guess the two main questions that we wanted to answer was, could we provide some sort of intervention to provide that source of propagules? Could we, bring this species back to Sydney and would it survive? And another one that I've sort of added, which isn't in this published decision framework, but I think is quite important, is to show that what you're trying to restore is not functionally redundant. So we wanted to show that the crayweed provided, some sort of unique ecosystem service and deserved to be restored. So I'll just touch on those two sort of scientific questions that we wanted to answer before we launched into our larger restoration program. The first thing was looking at whether crayweed was functionally redundant. And to do this, we did a number of different studies comparing crayweed with the species that had sort of increased in abundance or replaced it on the shores of Sydney, which were Ecology and Sargassum. And in these three separate studies, we showed that crayweed was in fact really, really unique. It provided these really unique ecosystem goods and services. So it supported much higher abundances of the economically important abalone. It provided or it supported really unique faunal communities when it was washed up on beaches and soft sediment communities in adjacent habitats. And the little critters that lived on and around the crayweed were also extremely unique. So this, I guess, was a really good reason to restore this species. And then the second thing we wanted to sort of show before launching into restoration was, well, could we actually do it? Was it going to survive in Sydney now? And, could we actually get it to reproduce? So we did a number of small-scale transplant experiments, and this sort of series of pictures here just sort of shows you the way that we transplanted crayweed. We attached male and female plants to wire mesh that we had bolted to the rock using sort of cable ties and rubber tubing. And what we found from a bunch of those studies was that transplanting crayweed into Sydney was successful. So both the survival and the health of the transplanted populations were very similar to our controls. Our associated communities, so the critters living on the crayweed, were quite similar to reference populations after 18 months. They weren't exactly similar. I think restoration of sort of associated communities is a long-term process, but it was certainly nearing those reference populations. And also, and this was really interesting, we found that recruitment of crayweed was actually way higher in our restored patches than it was in our undisturbed controls. And the reason for this sort of ended up being one of the reasons why this particular restoration program has been so successful, and that is that when you take these crayweed plants out of the water in the process of moving them from sites where they still occur into these restored areas, they simultaneously reproduce. So the male and female plants release their gametes, and when you put them back into the water, they immediately fertilise, sink to the bottom, and recruitment is very, very rapid. So the life history of this species made it quite, I was going to say an easy one to restore, but I don't think any species is easy to restore. And I guess, with the advent of all these omics, there was, one additional piece of the puzzle that we wanted to fill in before we launched into restoration. And that was, I guess, making sure that we were restoring something as natural as possible. So we used genomics to look at the genetic diversity and structure of the potential donor populations that would be surrounding Sydney, so the populations that we would be getting these crayweed plants from, so that we could mimic that as much as possible, but also to avoid inadvertently, for example, creating really low diversity populations that might not have, you know, the ability to adapt to future conditions. So we found 3 different genetic clusters around Sydney, and we used those to choose initially two of those to restore sites. This figure here is just sort of showing you the first 4 of those sites that we restored. And we also then collected the recruits in all of those restored areas. So the F1 generation, we genotyped those, and we showed that we actually had successfully mimicked natural levels of genetic diversity and structure that were characteristic of surrounding populations. Once we'd done that, and I should add that this was about 8 years of science, so it took a long time to sort of do all this, and there was very little funding. But once we'd done all this, we felt like we had all the little pieces of the puzzle in place to really scale up in a meaningful way. And we've now restored over 11 sites along the coast of Sydney. Some of those are really self-sustaining now and are spreading all by themselves. Others have required a little bit of ongoing maintenance. And along the way, we've really gathered, you know, a lot of community support and been involved in a lot of education, which is really important, I think, for restoration as well. And as Matt said, we were really lucky to win this Green Globe Award for environmental sustainability as well. I guess just before I finish, I just wanted to touch on one really interesting aspect of this project, and something that sort of am pretty passionate about, and that is a really interesting thing that came out of our restoration in Sydney was that Provenance Matters, so where you get these donor plants from, had a massive impact on how they performed. So we had much greater survival of all of the plants that we had taken from northern locations compared to southern locations, and this was in all the sites that we restored initially. And it was even despite the fact that we treated all of these plants very, very similarly. Our genetic data from further afield also show that the plants in the more northerly locations also have these loci under selection for temperature. So it appears that they're more thermally tolerant. So I think that these two things together kind of raise the intriguing possibility of whether we should in fact be restoring for, you know, for today's conditions, or thinking about using some of this information and some of this genomic knowledge to future-proof populations, or to, I guess, proactively boost their resilience to cope with future environmental change. And we've recently sort of published this framework for sort of choosing genetic baselines, and you sort of see here that, you know, most restoration programs fall into this recover stage where they're being done in the absence of genomic data. I mean, genomic data is not available for most species. Operation Crayweed falls in this revive because we actually did have a baseline to recover to. But I think more and more we really need to start thinking about moving into this reinforce or this redefined state where we do proactively try to improve things to cope with future change. And that's it. Thank you.
Thanks, Mel. And I think, yeah, in the end, you touched on one of that key questions, which is what is it that we're trying to do? 8 years of science. Well, 8 years of science from you, and I think Freda's work was 15 or more years of work. So you know, these are not quick fixes, and it does remind me of the old proverb: the best time to plant a tree was 50 years ago. The next best time to plant a tree is tomorrow. So you know, we do what we can, and we've got to start now. So I'm not doing very well with keeping you to time. We've gone just almost an hour. So a reminder to my speakers, if we can keep to the 12 minutes, otherwise we won't have enough time for the questions. So from here I will go from seaweeds in the Pacific Ocean back to the Indian Ocean, and thinking about, well, from large algae to small algae, the small algae that live inside animals, and of course we're talking about corals. So I would like to introduce Muhammad Abrar, who's from the Coral Reef Research Group in the Research Centre for Oceanography in the Indonesian Institute of Sciences, otherwise known to many of us as LIPI. Mohammed is a trainer and assessor on coral reef ecology and assessment, including being a dive master, and is in a PhD program at IPB University in Indonesia. So, Mohammed, I will hand over to you, share your screen and take it away.
Thank you much. I want to share the screen.
Yes.
Okay, you can see.
We can see. Thank you, Mohammed.
Okay. Okay, thank you much. Good afternoon, all of you. Good afternoon, and others, place. Today, I want to share a presentation about the Indonesian restoration from is the presented,
Pak Abrar, suara noise-nya ada di belakang. There is some echo with the people say something.
Okay, so sorry. Sorry. Yes, the presentation presented by the small team is from the marine ecosystem group, especially in the coral reef research groups. I call all of them Rico, Mandolasi, Triariono, Nuan, this is, I hopefully all of them also doing up in this. Okay, for the introduction, so I want to share information about the Indonesian coral reef. You can actually. We can see the simple map of the world. Indonesia is located as persists in the equatorial area. The 100% is tropical area. This I think is very good for the coral reef. So the coral reef, Indonesian coral reef covers about 25,000 kilometers square, or the 25 million hectares. It contribute to 18% of the coral reef in the world. And also is Indonesian government also committed to the marine protected area. I think is complete the coastal ecosystem, including the coral reef. The Indonesian targeted the MPA 20 million hectares in 2020 and 30 million hectares on the 20. So Indonesia also is center of the area is which is of 6 countries. Indonesia is widest coral area. I just said marine biodiversity and about the 65% is area. So is the consequence in Indonesian coral is the hydrosis coral diversity. The Indonesian have a total of more than 500 species of coral, and then we know that the species and we find it therefore endemic species. And then Indonesian is consists of more than the small islands, the unique in the ecology, geological tip and then reef geomorphology is the various reef tip here, that imaging reef, atoll, and so much reefs complete in Indonesian. So, in Indonesian coral reef status and trends, the big data was on the from the territories. We can see the fluctuated the coral conditions and the end of condition in 2019. We know that more than 50% is the coral reef in Indonesia under the needs. The poor condition and the dry conditions. So in general, the reef index value in the New Zealand is the average 5 ranks. They indicate that reef have medium coral cover with the high recovery potential, but low fish biomass. This I think is condition is improve to the how to fix the recovery for our needs. Then I think is restoration is one way to recover and restore for the needs. So in implementation, we also funded the restoration terminology and also rehabilitation terminology. This thing is depend in practice because it's the restoration and action bring the great ecosystem back and close possible to their original conditions. And then rehabilitation is replace part or sometimes the entire structure or functional characteristic of the ecosystem that has been lost. So the restoration implementation, generally the main purpose is restoration is to improve the quality of the great reef in terms of ecosystem structure and functions. Okay, now this the next slide we step to the restoration in action in Indonesia, how to process methods and then result restoration restoration in Indonesia. So for the case number 1, the linear community-based restoration in North Bali. This linear started into the 2010 with the input local community to restore using artificial structures. The structures method is like a shrimp pond, fish dome, and also roti buaya is bahasa maybe in the and this is like and in the linear progress until now is very good for the coral recovery, with the coral development, the fish succession, and also is the linear community-based restoration is education tourism was conducted in 2015 with the local community listening to what I do. So is the next case for the Indonesian coral restoration. is the sign ecological test for Panjang artificial reef. Is the experience restoration implemented by the university, the community, cooperation with the private sector, and also against the local community. With the specific concrete unit are designed like the natural structure of coral reef. And then the result is restoration, high superfall, and dog propora branching, and natural coral reef is replacement. The restoration is integrated to the rehabilitation, research, and tourism, and also good protection. Okay, the next case for the Indonesian economic restoration is techno-based bio Indonesia. This thing is generally method in the roots. Biorocks in Indonesia implemented by university, sector, NGO, and also community engagements. The Biorocks location in Jakarta, Bali, and Mangrove. The method is mineral accretion technology in placement media using electrical source. The results, mineral accretion, the coral transplant, and marine vectors settlements. So, in the case in Bali, Biorock Indonesia have to target for the 5-kilometer with restoration input to the 13 village, and that's 1,000 people, and then about the 200 kilometers square restoration. And also in the Biorock Indonesia in Bali, and the coral garden. This the Biorock Indonesia is to the tourism, rehabilitation, and its protection, and also for research. Now, we can the next case is the restoration Indonesian tourism base Nusa Dua Coral Garden. Is the restoration implemented by the university, NGO, private sector, with involve the local community also. The restoration location in Bali, Lombok, and Makassar. So the restoration method is artificial reef spider contraction with the surface. The result of the restoration will improve for up to the 50% for 2 years, and Acropora, Polyspora, and Turbinaria species on the coral will adapt to spider consumption. The restoration is good for the rehabilitation and tourism Indonesia. So the next and that restoration in Indonesia is environment-friendly biorefics implemented by the university and also involve the local communities. The restoration what area Indonesia, just in Bali, Sabang, Sampang, Madura, and artificial is units based on the coconut shell, the is, I think, is environment friendly because the coconut itself is a lot in some area in Indonesia. To the result is environment bioreactivities to accelerate the settlement of marine bentos, including corals, and then the study report that after 6 months will be covered by the marine bentos, including the coral larvae and schooling fish and pollution. The bioreactivity is used to the rehabilitation and in Indonesia. So the next is natural recruitment eco reef. The service implemented by the Marine National Park, university, and private sector. The restoration location located in Manado, North Sulawesi, is the method is artificial with design and specific material. In natural marine bentos recruitment and has habitat of reef fishes, improve reef fish population. Is study from CT1 or ZNCT. And restoration used to rehabilitation and also tourism and research from institution. So this the next case for the initial restoration is the stable artificial reef concrete block implemented the restoration implemented by government, NGO, public sector also improve the local communities. It is applied in the restoration concrete block applied in most of the Indonesian waters. It is the area in Indonesia. And then concrete construction is very set and completed by coral plantation. And the result is artificial reef concrete block enhanced to the habitat expansion is so shelter artificial reef for the marine bentos placement and this also is focused on the fisheries population. And the stable artificial reef concrete block used to the fisheries and its protection, tourism, and rehabilitation and restoration in Indonesia. So the next, the restoration method in Indonesia is coral propagation, transplantation. The method implemented by the government, private sector, and also involve local communities. The coral propagation transplantation in Indonesia is some area like Bangka Belitung, Lampung, Bali, Sumbawa, Sulawesi, and also Banyuwangi, Java.
Muhammad?
Yes?
We're just starting to run a little short on time. Another 2 minutes.
Okay.
Just 2 more minutes.
Yeah, okay. Yeah, and also the access for propagation. Thanks. Okay, I think it's the LIPI is supposed 2011. The LIPI sulfur is report the restoration proposal for the ornamental restoration and tourism, and also is system restoration system, direct transplantation from the and the others with this studies is preliminary study for the magnetic plants in the marine station, living marine station in Paris. I think it's nice. So, and we in Indonesian restoration if any problem and then evaluation for the next time. There's some high cost for wide area to cover, lack of monitoring, mostly only 1 year, lack manpower, local people to maintain, and also needs suitable restoration design are not specific, specific object and goal. The program has not been carried out, and the information of local specific are not considered. And the last is there is no protocol for feasibility study and assessment for agriculture. So there's some highlight for the implemented restoration in Indonesia. We need the regulation regulation and national policy for the restoration, scientific-based restoration, community-based for the restoration, and also the restoration design and adaptive to and environment friendly. Understand about the restoration.
One minute, Mohammed.
Yeah. Yes. Okay, it's the restoration for culture in Indonesia under government. We create the Indonesian Coral Garden in Nusa Dua Bali, and also in Indonesian Coral Center in Maritime. Okay, I think it's the last slides. We proposing the state that Indonesian coral restoration into the recovered coral reef with artificial reef and transplantation, and Indonesian reef restoration impact on the improve of the fisheries, tourism, irrigation, and research, and the target of Indonesia. The target of Indonesian reef restoration encourage support and contribute to the global issue, especially in the SDGs goal of 14 life below. Okay, I think this the last slide. Thank you very much.
Thank you, Mohammed. So one I guess observation, it seems to me, from seeing contrast between work that's been done on mangroves and seagrass and kelp and corals, is that even after many decades of work on corals, we're still struggling to restore them at scale. So clearly they're difficult to work with. Mohammed's shown us a few of the most promising techniques, but still we're facing a situation where the rates of loss are much higher than the rates that we can restore them and replace them. So we've got some challenges ahead collectively. But somebody who has solved at least some challenges is up next. So maybe we can learn a little bit from Dr. Chris Gillies, who's leads the Oceans program for the Nature Conservancy in Australia. And that means leading a team of restoration experts around Australia to deliver some innovative conservation projects for the benefits of both people and nature. So Chris works in partnerships with government, industry and the community at large scale to do the restoration work, which we are about to hear about. So over to you, Chris.
Thanks, Matt, and hello everyone, and hello to my colleagues if you're watching, and of course our partners and friends of TNC. I'm going to talk a little bit about a systems approach to restoration, and I'm going to use a case study focused on shellfish reef ecosystems. And by a systems approach, I mean thinking about not only the ecology associated with restoration, but also those other elements of restoration. So thinking about the social complexities and the political complexities that we have to face if we want to scale restoration and undertake large amounts of work within our ocean environments. And when we think about those sorts of issues and complex problems, we can sort of break them down into things like the science, like advancing the science and building the science base, the enabling policy and governance structures to allow us to undertake work in the marine environment, how we might scale our work that you just touched on there, Matt, and bring it to scale so we have that seascapes approach. And also how we might then mobilise the finances in order to pay for our large-scale restoration. And if we design programs and think about programs that look at all of these elements collaboratively and together, not just in isolation, we find that we can have some benefits of a systems approach that are different if we were just tackling these as sort of individual themes one by one. And that's looking at things like overcoming opposing forces where you know, the finance is lacking against the science. And we'll look at things like positive feedback loops and being more efficient and effective. And I'll go through those as we go through the example. If you're unfamiliar with what an oyster reef or a shellfish reef is, it works very much like a coral reef. And one of the ways I would describe them is that they're small natural features in the landscape. They're a little bit like a desert oasis in their importance, in that they really do harbour high amounts of biodiversity in a very small space. About 6 years ago, the Nature Conservancy in Australia first started its Oceans program, and we focused on oyster reef ecosystem for a couple of different reasons. But one of those reasons was related to the issue that we knew very little about the ecosystem, but we knew it was once common, and that we had lost a lot of it. And you know, that story is similar all over the world. When we looked at the baseline, where did we start? We had limited scientific information about the ecosystem. There were less than 6 publications in Australia that described an oyster reef or spoke about oyster reef ecosystems. There wasn't any funding available for restoration. And because of those two things, there was low government awareness and community awareness and no efforts to protect the ecosystem as well. So that's where we started from about 6 years ago. When we look at the different themes and we tackled all of these in synergy, so together at one time, you know, the first thing that we did was look at the evidence base, you know, build the science out. What was the science telling us? What could we do relatively quickly to get informed? And so and that's a number of university partners and government partners, as well as the Nature Conservancy, began to undertake some pretty rapid assessment of the historical ecology of the ecosystem, how humans used to use it. And in fact, we used to fish it and mine it and dredge it for a number of years. We also commissioned some descriptions of what the ecosystem looked like. What were the benefits? Why did it collapse? That science helped inform a number of different things. It's been fed into policy, which we'll hear about in a moment. Importantly, it created some compelling people-focused stories when we begin to dive into the history of the relationship between people and this ecosystem. But it also provided us with the technical support to understand how we might go about restoring the ecosystem at scale as well. And I think you know, the current output there is within that sort of fairly short period of time. We've had about 25 publications. There are now 14 universities involved in researching this ecosystem, and we now have incorporated a lot of that knowledge into government agencies and government agency reports. The second element there, when we think about strengthening the laws and the policy and governance structures to enable restoration to occur, a quick way that we did that was to establish these technical advisory groups. So a collaboration between industry, science and government to try and tackle some of these problems around projects and around some of the pilot projects that we first started. We also looked at how we could assimilate or build into normal environmental management plans, environmental reporting, oyster reef ecosystems and shellfish reef ecosystems, even if it was only just to point out that we didn't have much information about them, but the ecosystem was once there and that we should look to invest in understanding more about that ecosystem in that location. And we certainly undertook a number of one-on-one conversations with many different government partners and institutions, as well as the private sector, aquaculture sector, and lots of community groups as well. Those activities allowed us to address a number of policy bottlenecks, and in particular, things like permits and biosecurity risks and risk management. So we could work through those collaboratively with all the right people in the room. It allowed us to more efficiently get to scale in terms of being able to put things in the water and begin to test the process of restoration and begin to restore these ecosystems. It's also allowed us to advance or really fast track the protection of the ecosystem, where now we're fairly confident this ecosystem will be protected under federal or national legislation. And it will be afforded the highest level of protection as a critically endangered ecosystem as well. The third element there around how do we improve the efficiency and scale of interventions. So we worked with government as well as the philanthropic community, so trusts and foundations and a number of individuals, to fund about 8 different projects around Australia. They're all fairly large in size, between $1 to $4 million each, Australian dollars each. And there's some risk there in that we didn't undertake 10 years of science before we started our restoration approach, but we leveraged a lot of information that we knew was relevant to Australia from other parts of the world. And so we sort of tested those approaches fairly quickly, and then we looked to scale fairly quickly as well. Some other activities that we did is we made sure we brought in the public through things like a shell recycling program, a program where we recycle oyster shells and mussel shells. And you can see some of those in the picture behind me. And we also were able to, through the media and through newspapers and other reports, gain a fairly high profile around the project. And that helped us attract further supporters, financial supporters and community supporters as well. By having these projects in the water, it allowed us to work through some of the policy issues that we spoke about earlier in the last slide. And so we could solve those issues around real projects rather than just sort of hypothetical projects. It also allowed us to apply the research on the concurrent research programs and begin to learn what we had discovered earlier around what the ecosystem was like and what it may have been like in the past. And of course, we were then able to look at the publications to support the stakeholders as well. And so the outcomes there is that we were able to have a number of different projects in different political settings, social settings, and environmental settings, and learn from those collectively and begin to build a much more rigorous approach of moving forward. It also allowed us to gain confidence in establishing a national strategy for how we restore the ecosystem, and I'll talk about that in my last slide. The last one there around mobilizing sustainable finance. So we looked at working with philanthropic partners to provide support, and importantly, we spent a fair amount of time looking at the job benefits, the job creation benefits and the economic benefits that would be derived from undertaking restoration, not at a small scale, at a pilot scale, but if we were to accelerate our work and begin to restore at a large scale. And so we used very similar analyses and similar reports to any other infrastructure project, be it a road or a rail project or an airport project, and came out with similar sorts of numbers. And the bottom graph here on the right there is just an example where we know for every $1 million that we spend on restoration, we get about 4 direct jobs involved in construction and another 4 jobs involved in other benefits to the community and to other groups. And that provides a very compelling case then for government to invest in restoration, in particular in times like this where we're focused on stimulus type projects as well. So that's something that we sort of did that I think is a little bit different to other projects. That again helps policy and moves that along. It also helped us increase the size and scale of restoration as well. And all of these things allowed us to broaden the revenue base or the finance base for how we actually pay for this work. And so it's not just government. There are ways that the private sector and aquaculture in particular can play a role in lightening that load, as well as philanthropy. And then now we're really looking at other financial models like a bond or a loan scheme as well. So all of these activities have allowed us to pull together a national strategy, which we launched last year to recover the ecosystem. There are about 10 sites around Australia now. Some of those are ours, some of those are our partners and friends, but pulled together a very simple narrative around why we need to restore the ecosystem. And we know that we had lost 95 of the ecosystem. There's only 5% of oyster reefs left in Australia, at least in the southern part of Australia. And we're aiming for a 30% target, which is 60 reefs or 60 sites around Australia at a cost of about $100 million. And that would equate to 800 jobs and all of these fantastic services that we know nature provides. So in terms of water filtration, removing nutrient pollution, productivity, fish productivity, and saving waste and reducing waste to landfill. These sorts of numbers are fairly compelling to government and other partners. And, you know, I hope whilst we haven't got a significant announcement yet from the government, we're confident that very soon we will get some significant investment into this project. And this will then pave the way for other projects to also get funded, like a seagrass, mangrove, and kelp and others as well. So we're sort of hoping that we're providing a pathway for other programs to sort of take the whole approach between the community, government, researchers and the not-for-profit sector to be able to pull together these compelling strategies to restore ecosystems. So I'll leave it there, Matt. Thank you.
Thanks very much, Chris. And there's really a lot to learn, I think, from the approaches that have been taking around the shellfish restoration in Australia. And thanks also for not only sticking to time, but saving us some time, which gives us an opportunity to address some of the questions that were coming in. This panel has done a really fantastic job of answering the questions as they've come in, but I might cherry pick a couple of them for a bit of a collective conversation over the next, how long have we got? We've got just 20 minutes left, so maybe 2 questions that we can get through as a panel conversation. One question which came in from Umi Zakia, which was addressed to Dr. Sawandi, was around working with communities. So Umi's question, which was around how in Indonesia, working with local governments and communities sometimes ends up with conflicts. But it does raise that broader question of how we work through restoration with communities. So I might ask everyone on the panel to provide a little commentary on that, perhaps in the order that we spoke. So maybe starting with Freda, then Sawandi, then Muhammad, and then Chris. Freda.
Okay, thank you, Matt. I think that for the questions, how we can work together with community and avoid the conflict. I think there are a lot of studies about how the mangrove plantation can give benefit to the community, but the problem how we manage the community, and it's also very important to show them like give them like sort of like public awareness, education, and then what the benefit for the livelihood. So with that kind of things, we can also avoid the, let's say, the conflict about the land tenure when people want to restore the mangrove, but then in the future they want to convert again into the other land use. I think that's the main issue in Indonesia. Yep.
Thank you. Good point. And the comment about livelihoods, I think, reminds us of Chris's slide on the narrative there. Sawandi.
I think the way that you will have to handle this issue is to first, as Freda said, work in very closely with the communities, but also to emphasize the fact that the conservation will have both direct and indirect benefits, some that you can feel very quickly. And in order to make sure that we resolve the conflicts, I think it's very important at the very onset of a project, you look into socioeconomic benefits that the project can reward to the communities. One of the biggest problems with regard to mangrove restoration is that unfortunately it's not the communities that are living around that create the biggest damage to mangroves and other coastal ecosystems. These are large scale industries and perhaps stakeholders coming from elsewhere to do industries. So that when you sort of like work with the communities at the ground level and emphasize them the real worth of the system and why it is important that it is protected, because their livelihood is very much an integral part of the ecosystem, they tend to sort of come in and support you. However, one very important thing is, I think in every project, we need to quantify as a monetary value the benefit that the communities are going to get, and we are not doing it 100%, and we sometimes just look at the science and ignore socioeconomics. I think it's very important to combine and have a balance of both of them. Then only we can reach the community and convince them.
Thank you, Sawandi. And so a good point about the, I guess, the decoupling between those who receive the benefits from the ecosystem and those that are perhaps creating the impact on the ecosystem that needs some consideration. How do you think we can approach it for coral ecosystems, Mohammed? I think you're still on mute there, Mohammed.
We know that the restoration program is a long time program. Is in a problem for the local community because it's the income is every day, and I think the restoration program will be the alternative income like tourism and other maybe, because it's if we the waiving the restoration success is very long time is I think it's no good for the local community because it's every income get income in every day. Thank you.
Thank you, Mohammed. So again, thinking about the benefits. And Chris, I know this is something you've put a bit of thought into. So what do you think?
Yeah, well, certainly working with the community could be a whole program in itself, and I think it's a heavy burden on any single organisation to be focused on the science and the practice of restoration, as well as really working to manage community expectations and education as well. So the approach that I guess we've taken is to try and collaborate and work with other organisations where that's their expertise. And they have that specialty of working with the community, and then we bring them into the program and we find roles for them as part of the restoration projects. So for instance, that might be cleaning shells to help with preparation of the reefs. It might be part of the monitoring part of the reefs. It might even just be to inform where the reefs are, but we often work with partners. And probably the second point there is that we do put a lot of thought into making sure that we have our key messages developed before we start engaging the community, and we actually have some preparation because you know they do come with expectations, and they you know rightly so can be skeptical sometimes of restoration, and so thinking through in advance what some of our responses might be to those questions, and then working with them to bring them along for the ride seems to work quite well. But yeah, it's certainly a lot of work that needs to go into working with communities, given it's their backyard, as well as everything else. So working with partners and thinking about key messages is some things that we've learned along the way.
Some good thoughts there. And, you know, I think a key one is not just thinking about the distribution of benefits, but your point about participation, I think is a really good one and a key one. So another question, a few more have come in. So a question from Freda Siddiq around collaboration or correlation with restoration among different habitats, different ecosystems, so mangroves, seagrasses, coral reefs. So I guess we're thinking about a broader landscape or seascape scale approach. A very good question. Among the panel, is there anyone that feels like they want to answer it, or shall I choose someone? Ooh.
Matt, I'm happy to talk a little bit about the work in the oyster reef world. So there is some work that gets done around the collaboration between the different ecosystems. And we find that sequencing can be really important. So the Nature Conservancy used to do a lot of seagrass restoration in many places in the US. And some of that was successful, some of that wasn't. But we began to learn as we put more and more oyster reefs in that seagrass would naturally colonize in and around the oyster reefs because the oyster reefs were providing that role of reducing sediment and allowing more light attenuation and also providing nutrients in some nutrient-limited areas. So we actually found now that many places we install oyster reefs and that changes the dynamics of the coastline to either allow seagrasses and or salt marshes and mangroves to colonize in behind some of the structures in the reefs. So there is some of that work going on, but I would probably say it's nowhere near as sophisticated as it probably should be and probably will be in a few years' time. And I think, you know, the more of these sorts of forums we can have of having a diverse range of expertise in the room and start to co-design these sorts of projects, I think we'll be able to advance that a lot further and fairly quickly.
And so that's a great example of some of the, I guess, the positive facilitation from one system to another. Freda, you gave an example of how you can actually negatively impact one system through inappropriate restoration methods in your example of planting mangroves in a seagrass meadow. Did you want to have a comment on how you might want to start thinking about sort of a holistic mangrove seagrass restoration approach?
Yeah, I think even with the coral reef, mangrove, seagrass, and coral reef, like if you think about only for mangrove, so people just neglect but seagrasses, and maybe they plant mangrove on the seagrasses. So they don't understand that they kill seagrasses by store the mangrove. So it's sort of like we need like a good plan, not only for mangrove restoration, but for, let's say, if that coastal area have not only mangrove, but they also have, like in Bali, they have seagrasses and coral reef. So we have like an integrated map in that site before we do restoration. So we know what's happened in that area. And then after that, we kind of set up a good plan for mangrove where we have to do the restoration. And then because if we restore the mangrove, it also help the coral reef from the high sedimentation, and perhaps with seagrasses, they connected because mangrove are linked with seagrass and coral reef. So yeah, I think that's always we talk to people in the mangrove forest, not only thinking about the mangrove, but you also have to think about the nearby environment in the mangrove. Yeah.
So there are potential positives, as Chris has pointed out, but if we do it the wrong way, there are potential negatives, and we need to be thinking that through.
Yep.
Another question that's come through, which is about youth and how we can encourage getting young people involved in restoration. I know that a few of you have thought about this. I might start with Chris again, and then Sawandi, if you can comment, and then we'll go to Freda and Muhammad.
Yeah, that's a great question, really, around diversity, equity, and inclusion of youth and everyone. We've had some success working with schools, and namely around thinking about, again, locations and running a concurrent school-based program as a great way to begin to work, I guess, with young people to understand what restoration is. In some aspects. In other aspects, we're getting them actually involved in the work where they are helping us with monitoring programs. So they may be directly involved in counting oysters and going out there and recruiting oysters. And we have one school that's actively involved in the aquaculture of oysters and helping to grow oysters to seed and mussels to seed on some of our reefs in your backyard over in Perth. So we find the schools are the easiest way to get involved and the most structured way to get youth involved. But there are certainly other ways. But yeah, there are, I think when you put your mind to it, a number of different ways that we can engage school children in various aspects of the program.
Mm. Sawandi. You're on mute, Sawandi.
Yeah.
There we go.
Yes, here we are. So to engage youth and youngsters with coastal ecosystems, let it be mangroves, seagrass, or any other ecosystem, I think the greatest potential there is first to make sure that we take them physically to the system itself, to make them understand that we are not just talking about a set of plants here, but that whether you are interested about butterflies, moths, fish, or birds, that this is an ecosystem where you can actually get something. It's not just about learning, but also recognizing the fact that these systems provide you a lot of services. And that kind of activities, and especially at the Ministry of Environment Biodiversity Secretariat for the last few years, we've been engaging with lots of school activities which ask children to paint your future surrounded by nature. And that has been quite effective in them understanding that there's more to do in ecosystems than just reading about it and being aware about it. I can be a part of it. I can do something back. I think what is really required is not just giving the knowledge, but creating the right attitude to be a part of the system. The moment you have a generation that has the right attitude to be a part of the ecosystem and also willing to take up the challenges, life becomes easy.
Thank you, Sawandi. Freda, did you want to comment on this one?
Yeah, we also work with youth every time, especially in our office. We have like a regular visit of the school children. So for the mangrove activities, like instead of like we doing plantation, so we introduce to the school children how important, like give them some information, education, and also we have a program, we call it mangrove cleanup. So we ask them to help us to pick up the rubbish around the mangrove forest nearby our office. So we tell them that this is the plastic debris is very dangerous for the mangrove as well, not only for coral reef. So by cleaning up the mangrove, you also help us to restore the mangrove. And also we use another channel like the social media. We have like competition about mangrove vlog or mangrove photography competition, something like that. So to increase the awareness, and then we also send them like the books about the mangrove biodiversity, the guidelines for free for school children.
Yes, social media, of course. Mangroves on Instagram. Why not? Mohammed, comments on...
Yeah. Thank you, Matt. I think it's very important for the young people in the course because it's the next generation future. Make it ecosystem. So our experience is under former programs in the last time. We have deployed the local curricula in the formal education. Will be the special marine education in the formal education for the elementary school, junior high school, and also senior high school. Thank you.
Thank you, Mohammed, and thank you all. And I think the examples given with school children are really good. I run a program every year as well where I bring the school children of a town in the northwest of Australia to the beach, and I do an education program on turtles, and that's a highlight of the year for everyone. We all enjoy it. Now, we have only got just 2 minutes left, so I might go from youth to wisdom, and I might hand the microphone over to Andreas once more to give us a summary of what you think about restoration. Andreas.
Yeah, just this morning, I have also a webinar regarding the restoration in the Riau province. They are trying to link among private sector, local government, community, and as well as NGOs. So the program was, I think at the moment is goes on the right way, but now they are thinking about the sustainability of the restoration. From your presentation, we know that restoration is a big spend, not only times a lot, but also some other effort like money, something like that. And then the result can be seen in the next few years. It's not instant, something like that. So there is some gaps in the between that we need to think that when we are starting from tomorrow restoration, and then the result can be seen in the next 2 years, for example. So from tomorrow until the next 2 years, what will be happen? This is we need to think as well. What is how to fill in the gaps, because the local community, for instance, they need as well to do something. We know that the many activities of them are not good enough for the environment, but we are trying to educate them that we need to sustain the environment. Otherwise, you will have more or bigger problem in the future. So I don't know the answer yet of this gap. Yeah, but of course, to destroy the environment is something not good anyway, and to restore the ecosystem is the best way, but it takes some time. But we have to starting now anyway. So I think that's our. I open the question. Maybe yeah. This is what I'm thinking of when I'm going to the grassroots, thinking about the people. Thank you, Matt.
Thank you, Andreas. Yes, so the only way to start a long journey is to take the first step, and I think that's what we're doing. So with that is our time. Now, questions that have come in around the YouTube recording, we will post the recording on the Kemenko YouTube channel, I believe. So I think the link will go out once that's done. Some requests about access to the presentations that we've heard, the 5 presentations. If we have agreement by all the presenters, we will also share their presentations. We'll put them in a PDF form, I think, if they agree, and we'll share them. So with that, I will close the webinar. I will say to Freda and Mohammed, terima kasih, and to Sawandi, I will say stuti, and to Chris, I will simply say thank you.
Thank you.
All right, and thank you, everyone. Goodbye.
Thank you. Bye.
Thank you.
Thank you,
Bye.
Matt.
Thanks, everybody. It's great.
Thanks, Mark. Thanks all.